When evaluating an inverse function, the value that's in the argument of your function is usually going to be a value that we get from the unit circle. And because we're talking about the sine function here, we know that the sine represents the y-coordinate. So we're going to have some y-coordinate from the unit circle here inside the argument of our function. So if we evaluate something like the inverse sine of 1/2, let's say, what's our result going to be? Well, the value that we're going to get as an output is going to be an angle measure. In the restricted domain, in the restricted values, that gives us a sine of 1/2. That just gives us a sine of 1/2. So basically what this means, right, what this means is the sine of some angle is equal to 1/2. What is that angle? So let's take a look at trying to evaluate some of these kinds of problems. So we want to find the exact value of the inverse sine of 0. So again, this means for what angle is the sine of theta equal to 0? For what angle is the sine of theta equal to 0? Now, when we're talking about these angles, we have to remember that the inverse sine was restricted to quadrants 1 and quadrants 4. So quadrant 1 and 4. So that's going to be the values from negative pi over 2, right? Negative pi over 2 to positive pi over 2. So we're trying to figure out the sine equaling 0. So that's the y-coordinates. So for what angle is our y-coordinate 0? Well, we know that we get coordinates of 0 at all of our axes. So here we have 1, 0. Here we have 0, 1. And here we have 0, negative 1. So which of these angles gives us a sine value of 0? So again, we said that the sine is the y-coordinate. So which of these has a y-coordinate of 0? Well, that happens here at 0 radians. So the sine of theta is equal to 0 when theta is 0 radians. So that just means that the inverse sine of 0 is 0. So this is the value from the unit circle, and then this is our angle measure, so 0 radians. So that's how you would evaluate an inverse sine function.